Hey kids, this is Mr. Pickett, and I wanted to go through the, pull together of your little series and parallel activity. So the first question that I'm going to ask all of you is which orientation, series or parallel, gave you a brighter light bulb? Awesome. Hopefully all of you said parallel. Parallel gave you a significantly brighter light bulb. Now, the question that kids ask is, well, why? Well, let's circle back to our earlier conversation today. What are the two things that affect the current of a circuit? You should have said that voltage changes the current, as does resistance. Now, I want you guys to think, did you change the amount of push? So did you change the number of batteries that you were using between the series and the parallel circuit you made? Nope. Okay. Did you change the resistance? Yes. Now you don't know how you changed the resistance, but because the brightness of the light bulb changed, which means that you're somehow changing the current, right? How do we change the resistance? Well, for that, I need a little bit of a whiteboard. So let's change this to share the screen. Let's just go to a whiteboard. Okay, so as I'm taking a look at this, we'll draw a series circuit. So we have a battery. That's a bad looking battery. A battery with two light bulbs, and you guys are gonna have to stay with me here as I'm drawing another light bulb really poorly. All right, so we have two light bulbs here. And let's imagine that this light bulb has a resistance of 5, and this light bulb also has a resistance of 5. When we draw the circuit and we build the circuit in this type of a fashion, in a series fashion, what you do with your resistors or your resistance is you add everything together. So we basically get 5 plus 5. So our total resistance of this series circuit ends up being 10. And if I wrote this, it would be R total is equal to R1 plus R2. Now, if we draw our system actually in parallel, then we get some changes. And again, I'm not drawing this perfectly. And then if I draw a circle, draw another circle. So I've got the same two light bulbs that were over here, each one of them having a resistance of 5. But when we draw the circuit in an orientation that looks this way, our resistance changes. And so our formula, instead of adding R1 and R2, looks like this. 1 over our total resistance, which I'm just going to write as an R. I should write RT. That's going to be equal to 1 over our first resistor, so 1 over R1, plus all of our other resistors, and it will be 1 over R2 here, because there's only 2 resistors. Now, when I plug this stuff in, I would plug a 5 here and a 5 here. And when I plug both the 5s in, I get 1/5 plus 1/5 is equal to 1 over RT. And so I end with 1 over our total resistance is equal to 2 over 5. Now, Nebraska math, what we would do is we would take these things, and I don't know how this is arranging it. Let's imagine the R is down here. If I change the R to the top and the 1 to the bottom, I get an R. So I have to do the same thing over here. So what I end up getting is R is equal to 5 over 2, or I get a resistance value in this circuit of 2.5. And if I have a smaller resistance than 10, then I'm going to get a larger current. So I wanted you guys to all see this, probably the learning goal that I wanted you guys to see today was that a parallel circuit changes the amount of resistance that is actually affected, or the amount of resistance, excuse me, in the circuit, and therefore changes the current. All right, hopefully this helped everybody, and we're going to take this tomorrow and we're going to add some more math into it.